That's tough.
I can't buy it anymore. I already bought it all.
Okay. Hey, we're gonna go through the outline real quick. I got a couple examples I'd like to talk through.
Outline? Do we have a test? What?
I said I'll have to tell her
That's wild.
Okay, all right. Anyway. Okay, here's what I want to review. I'm going to correct people again. So, differentiation, we're going to go through power rule, product rule, quotient. I'm just going to do one example, not two like we did Friday. Just get us back in the swing of things. We do have chain rule. We're going to do a ton of these today. I think I have 5 examples picked out. And they're going to range in difficulty. And then we're going to look at homework. Homework that I'm going to send today we'll be doing Wednesday this week. All we have to do is when you go through it, all you have to do is set it up. You don't have to like simplify it all the way down. So it should be easy enough to go through and do the setup. That's why I'm not giving you too many days. Because if you do the first line, you know your shortcut to do the power rule. That's all you can leave it at and move to the next problem. Does that make sense? Because I understand you can simplify it. I totally trust that you can actually foil things correctly. It's just a waste of time going further than that. Okay, so we're gonna get to these examples. I'll show you what I expect when I do my first example, then I'll have you guys try out a couple. Okay, all right. This is the power rule that we talked about on Friday last week. The example is if I had this. Ooh, that 7 should have been a power. Sorry. I didn't realize you got entered down. But anyways, let's say that's a 7th power. Sorry, I don't know why I corrected. What you do is you drop this power down out front, and it multiplies on the 8. And then you subtract 1 off the power. That's the rule. But if you have a bunch of things being strung together, added and subtracted, you just do each one separately. So the next one would be 4. You drop the 4 down, you subtract 1 off the 4. You drop the 1 down off the x, and you subtract 1 off the power. That's how it always works. Doesn't matter the problem that you have. Eventually, this problem will eventually come down to 56 x to the 6th. 4x to the 3rd, 10, and there's no x on it. If there's any constants, those are trying to be zeros. Okay, do we feel comfortable with the power rule?
Yeah.
Okay, we've done that one quite a bit. I think that was last week we introduced that. Okay, we're good though? Perfect.
Is that our home? No, we already had that.
Yep, we already have that.
You didn't write it down. Is that what you? Our new homework.
No, I haven't read
I
that.
wish you would have.
Okay.
Yeah, work today.
Okay. So, all right. Now, I'm too zoomed in. I think I'm too zoomed in.
I agree.
Okay. So, on this particular problem, now we have a product where we have multiple things being multiplied together. You do the derivative of the first times the second, derivative of the second times the first. I'm going to put it over here because I don't want to walk over there and get in the way of the PowerPoint.
You're right.
So, finding the first derivative, the derivative of the first parenthesis is going to be 4x to the 3rd plus 7. That's the derivative of the first times the second, which is x to the 3rd plus 5x squared plus x. Now, we're going to add in the derivative of the second. Okay, derivative of the second. 3x to the second plus 10x plus 1. And the first is the x to the 4th plus 7x. So there's the derivative. That's what I expect to see probably on a test day. I'll kind of where you just do the first couple lines. That way we can get through multiple problems where I don't have to have you wasting 20 minutes trying to foil it all out and whatnot. But again, that's the product rule. Derivative of the first times the second, derivative of the second times the first.
That's all we need to do and we're done?
What?
That's all we need to do?
It's up there. It's just 2 lines.
So that's all you want us to do?
You should do a persuasive speech on
What?
that.
That is the beginning part up there. That's the problem over there. This is the beginning
Yeah,
part.
that's the
Oh.
yeah, that's the problem.
I thought you were.
No.
Well, that's as far as you want us to go?
Yeah.
Okay.
Okay, and I'll warn you on certain problems, certain test questions when I want you to go further when I don't.
That's as far as we need to go.
Yeah, they're really annoying.
Not gonna do it. Not gonna correct those stupid attention. Not in the mood. So. Okay. Quotient rule, derivative of the top times the bottom. So derivative of the top. This particular problem is going to be the 3x squared plus 8x. The 7 goes away, it turns out to be 0. We take it times the bottom. That's x to the third plus 8x. And we're going to subtract the derivative of the bottom, which is 3x squared plus 8. And that's times the top, which is x cubed plus 4x
Hey,
squared
you need to close off your other.
plus 7q. And over the bottom squared. The bottom squared is going to be the 3x plus 8x squared.
You're being a hypocrite.
Alright,
therefore.
no. So, okay, that's what I expect to see, especially on the test questions where we have. Test for us will probably be, I don't know, maybe
2 weeks.
Tuesday next week.
I think.
We'll probably start to see a practice game maybe the end of the week, because we're coming down to the last part of the section. All we have left is graphing to do with this stuff left, which is the next couple sections. Yep, we always do. So we're going to look at that next, and then we'll get into the next unit after this. So, but these are like some of the test questions. You have a couple where you have to do division rule, quotient rule, and that's what I expect to see. I'll probably say like don't foil it all out, just write down the first few steps, done. Okay, that's, I consider that the first few
You
steps.
should say there is no need to foil this problem out.
Yeah. Okay, questions at all about that?
He didn't even write. Nope.
No, sir.
Yeah, I'll come up with something that's grammatically correct.
Thank you.
So, all right, moving on.
Say, put it in the dumbest version you can.
So that we understand it.
Chain rule. All right, this is the last example. This is the one that your homework's based on today, but again, your problems won't be nice and pretty like this one. So we gotta get used to like the different looks that they can do. So that's why like the 5 problems, because I'm gonna do this one, I'll do the next one for you. I'll show you why I picked out like 5. I kind of picked out a range of different things that they look at. They look at radicals. They look at when they have e to something. They look at when they have a number to some power. So we're gonna look at like a bunch of different ones, and we're gonna try to apply the chain rule to them. And I'll try to show you my shortcuts, ways that I've attempted them. Again, there's more than one way. We even saw that Friday when we attempted chain rule, is that there's more than one way to do these problems. But I want you to see the shortcut, like the shortest way possible, so that it makes sense to you. And then that's the way, and again, you don't have to foil it all out today, especially on the homework. I just want you to do your normal math on that. Question?
So in those, why would they have the E?
Why would they have an E? It's usually like in the middle of that problem, they could put E to some power. That's probably what they do. Because when you're taking a derivative of like a curve, curves typically like a curve that we would use in like an engineering course or some type of like sciences would be natural growth, right? E, when you're looking at bacterial. Well, the idea is that they're looking at rate of change, that's why the E comes up. Because that's like
Seems
the
like
more,
they just throw it in there so randomly. I didn't know.
no, I mean, the most time when they're doing a problem, it's usually for like growth problems. That's why they actually look at like first derivative or second derivative for
So we
it.
take the 4
So,
down to
yep.
the front.
So first derivative, yes, you're absolutely right. First derivative of this, can everybody see the green?
Yeah.
Can you see it over there? Okay. So you drop the power down, keep going.
Then we put what's in the parentheses,
Okay, good.
and then we subtract 1 off of the 4,
Okay, good.
and then we add the derivative of what's in the
Multiply.
Multiply?
Multiply. Okay.
Multiply what's in the derivative of what's in
Yeah. Derivative on the inside. 5x to the fourth.
Plus
18x plus 5.
We multiply.
We multiply the derivative of the inside. Now, the reason why this all came about, and I didn't really talk about it too much last week, chain rule is really doing your product rule like multiple times, but what they're doing at the very end is they're pulling out the common factor, and that's what you're seeing there. Those would be all the common factors in every problem. So that's why the chain rule looks like this, because it's actually in the product rule, you write 4 parentheses, you do your work for finding the derivatives, but then it's pulling out the common factors. So that's why it would turn out to be this in the long run. It was just that we don't have those skills to do factoring like that. We have like grouping and common factors. And this is like beyond that. That's something that I wouldn't even attempt to do. I wouldn't even do it.
How long would it take you to factor that?
I don't even have the skills to be able to factor that to this point. That's why doing the shortcut.
You can't do that?
No.
Oh, lies.
So, questions at all about chain rule, like the general rule of it?
No.
Okay, let's take a look at, I'm gonna do the next one for you. It was one that was very similar to what we did Friday, just to show you the shortcut again. Because some people like, I think it was Tyler, I think did it when we were going through around the room. And I just noticed he did his problem very different than everyone else because he saw the shortcut right away. That's the way I would have done it. But then I picked out like 5 more problems I want to look at before I hand out homework. And we're gonna try to go through these quick. Okay, so I'll give you a little bit of time to work on this question. I thought it was. I thought you did it like different where you raised, like you didn't write it as a fraction.
That was me.
I didn't do it at all, so.
Oh, I thought you did. Alright, moving on. Maybe that was a different problem I was thinking of. Alright,
Nicole just said it was over.
well, I give you credit. You should have just taken it.
It was
Alright, so.
Nicole, she just said she did it.
Oh, you did?
I think it was me.
Okay. So, sorry. Didn't mean to. Alright, so here's my first problem that I want you to do. Okay? So this can be the one I want to talk about, like the shortcut, how I'll do the chain rule here, but then I'll show you a completely different way to look at this problem. Does that make sense?
No, you didn't.
Alright, so,
One day I did something different.
Okay.
Yeah, and then you.
But I don't know what day that was.
okay, here's the derivative. Now this contains the chain rule inside of it.
Because it has the negative exponent.
Okay, first, derivative of the top, that's just a 1, times the bottom, which is x to the 4th plus 7x squared to the 3rd power.
Factor that one?
So, we subtract the derivative of the bottom. The derivative of the bottom is the chain rule. So the derivative of the bottom is dropping the 3 out front, going x to the 4th plus 7x squared
To the second.
to the 2nd, because we have to subtract 1 off the power, and then times the derivative of the inside, which is 4x to the 3rd plus 14x,
Times the top.
and then we have to take it times the top. So, if that makes sense, like that's, the derivative of the bottom is actually a chain rule times the top.
Wait.
Oh, because the chain rule is only for a derivative.
Yeah, yep. So when I did the chain rule, it was because the bottom, when I took the derivative of the bottom, that was a chain rule, and then I had to take it times the top again.
That confuses me because I want to do
Yeah.
it for the first one too.
Yeah, no, and then then squaring the bottom, I have x to the 4th plus 7x squared,
Ow.
and then we're gonna square
6.
a 3rd, which you're right, would be a 6, because that's just putting a power 2 on the 3.
That is so cool.
So, okay, that's what I expect to see, that's like what probably most people would attempt. Because that's the way I probably would do it right away. Unless you start to see shortcuts, where you can change the problem completely different. Like, for me, like, I can do that problem completely different than that,
I'm
where,
gonna cross out the little things.
where,
Why are you multiplying that thing at the?
Because that's the chain rule.
yeah, so it's derivative of the top
Uh-huh,
times the bottom,
uh-huh.
minus derivative of the bottom times the top, right? Because that's how the quotient rule works.
Oh, yeah.
Well, the derivative of the bottom is a chain rule,
I know.
and then you still have to take it times the top,
I
right?
forgot what the chain rule is.
It's, you drop the power, you do the normal thing, and then you just take it times the derivative of the inside.
Okay.
Okay, now, I'm gonna change this problem up so we do it differently. Okay, so this is how you could attempt this problem differently. You could change it like this. X to the 4th plus 7x squared to the negative 3. So
What?
I could bring the top up.
Did you see the?
So this is the way this is I think the shortcut I was showing on Friday.
Yeah, you were.
That you could bring this up, and now you're just doing a product rule instead of a quotient rule. Because maybe you're better at the product rule than the quotient rule, so it might make more sense to you.
Wait,
So-
this is what you did?
No, I didn't do this, but I understood exactly what he was
I
doing.
know
Yeah,
it's gonna
so,
explain it.
alright. Again, if you can't see it, just let me know. But if this is a product rule, you do derivative of the first times the second plus the derivative of the second, which is this.
You can just leave it like that?
So the derivative of the second is drop the power because it's a chain rule, times that, times the derivative of the inside, times the first.
That seems a lot harder than the other way.
Now, yeah, some people don't like that. They don't like to see the product rule. The product rule for some people doesn't make any sense. Like, they just don't like it. Like, to me, the product rule is fine. Derivative of the first times the second, derivative of the second, which is this monster, times the first.
Why does that turn into a positive?
Yeah, why is that a positive 3 right there?
Where?
Do what you did.
And a -1, yeah, right there, in the second, the
first
first
term.
parentheses.
Oh, this?
Why is that third at the power?
So,
Why is it a
oh
third,
yeah,
not negative?
you're right.
Okay.
Right.
But I'm still
That's a fourth.
confused, yeah.
That's a fourth.
Thank you. I was just
Yeah,
a
yeah,
little,
yeah.
I was just a little confused.
Yeah, I didn't notice it, it doesn't make sense. Alright, so derivative of the first times the second, derivative of the second times the first. And you add them together when you do it. Now again, that would be actually subtracting on that one because of the negative sign dropped out front. Notice that the power turned out to be a -4.
What if we did do plus and negative? Is that fine?
That's fine. That's the way I would probably write it. Now, again, I'm not foiling that all out. Again, I know this seems really weird. This answer and that answer are exactly the same. It's just been simplified differently. So, they're the same. I expect more people will probably do that one. That's what I'm expecting, because most people see it as a fraction, so they'll label it as a fraction. I don't mind that. So I'll kind of look at how you did
Throwing
it.
in negatives like that's
Now, if you're going to change your problem before you start, I ask you to at least write this down before you start the problem. Does that make sense? I want to see what you're doing first before you attempt to take the derivative if you're going to change the problem. Okay? All right, next one. All right, massive chain rule here.
Holy.
So we have the fraction over, or we have the radical over everything,
Half power.
half power.
To both
Then-
sides.
Yep, and then we're gonna do the quotient rule for the derivative of the inside. So if I'm doing a purely a chain
What do you
rule,
mean? Can we do this and then we check the note?
yeah, that's fine, you can do it.
Cool, 'cause I wanted to
I
find
don't
out.
care, so I don't remember. Okay. Fair enough. I appreciate you being
I'll give
honest.
I'll give you a couple of minutes to write this down.
Wait, I have a question.
Can we use?
Does the half power go to both items?
If you wanna do it that way, you can just do the half. I would just leave the half on the outside and just do like the chain rule.
How do you, I don't know.
Didn't you say it's bad to take everything?
Like
On the
half
x squared plus
power
minus zero on
on
that
it.
one.
Because it's,
Leave it on the x squared plus minus.
I'm just trying to get it.
No, you put on like everything, just leave that half power and everything. And just do it like a chain rule.
I don't know, he's talking about the chain. Can we just do the thing and then put it all under a square root sign?
I don't know how it's thought.
Can we just,
not?
Like the derivative of the inside and then just put a big radical on it?
Yeah.
No, that's a different answer.
so then we just have to put a half, our only choice is putting a half hour on both.
Because you gotta do the chain rule, or you have to drop it out
Is
front,
that
subtract
our
one
only
off.
option?
You could, yeah, I mean, the only way to
That's what I
change the
thought,
rule.
that's what I thought.
Wait, so it's gonna be like negative?
How do you chain rule for this?
For the power, eventually.
Yeah.
Yeah, eventually it would.
Okay.
I mean, this thing's
I'm
big,
just like
this
trying to think
thing's
of it in my
big,
head.
and it's bigger than you think it is.
Really?
Yeah.
Great.
So I don't really understand how we go about this.
Okay, yeah, that's why we need to talk. That's why I picked out like 5 of them that we just need to talk about, because the rule is so weird that we just aren't used to seeing it. Like this, like having a radical over really big things. Or putting an e to
Are you
something
about to
really
do it
big.
already?
It's definitely
Can you get
confusing.
me? I'm sorry.
Oh, that's fine. That's why I want to at least practice with you. I'll walk you through how I would attempt it. I'll walk you through maybe maybe you want to change the problem to begin with. That might be a different way to look at the problem. Because there's a couple different ways you can see it.
If you square a half, is it just gonna be 1?
Yeah.
Thanks.
Wait,
You seem like
oh
you're
my
good at
gosh.
Would
It's
you
almost
look
like I
at this?
broke 5 different
No,
laws or
no,
something.
okay, that's not
What were the others?
We got.
Yeah.
This is the first thing.
Yeah, we see.
So, yeah, you're absolutely
What was
right.
it?
That
You
fraction.
wanna look at my next board?
The actual like chain rule makes the inside harder.
Wait, how does this work? How is
Wait,
this?
Reese. Reese.
Times 2x times x plus.
supposed to do the top one first. That's what I did.
Yeah, on this factor you wouldn't.
I think I did.
Oh, I think.
This is like the first part, and then when you take the derivative of just the inside, this would be the inside of these powers.
But other than that, it's fine.
Hey, Drowsy, I know what you're doing when you said you're gonna take a half times 2. You would.
On the bottom. It's just negative half, isn't it? Not negative
The way that I would do it, you wouldn't be doing
Sure,
it.
will you come check my?
Because I'm betting on, what I'm betting on is that you did the chain really drop the power. You
I'm
have
lucky
to
he
start-
hit you with a
In
55.
the back, when you multiply the derivative of the
Yeah.
inside, there's
You've
no
been
radical in it.
If I get caught,
If I
I
just
do okay.
X
Like
my
last
just
time
doing the
when I got my
derivative
ticket
inside.
from Untitled Windows, I was
Which is
just
no
65.
radical.
Didn't have any registration.
Oh, look.
And
Why don't you just carry your
and my,
registration with you? Is it that hard?
2 different cards, I don't know what they are.
Who would it- or-
No, I didn't expire the insurance card, not.
Did I at least get my top right?
And then my windows were 50. So So hit
If I did it wrong, it's okay, 'cause I'm always
Why won't
Oh,
have
so
square?
you did yours
So what do you get for that?
I see.
What
Okay,
about
so
one?
you're not-
What's this somebody
You have
that
to box
takes-
has
You're fine. The way you
square.
did yours is
No,
right. So
you
never
did
mind.
I have
it.
100.
That's the second way I'll.
So I'm gonna go to
That's
Casey's
the
at
way
school,
that you
draw
can get done, but we
$100.
can have it.
You give it to my dad and I go home. That's all I can afford to give him.
You're looking at that.
And I'll just pay him back later. Pay the
That's
rest.
such a shame. Don't you have a
No,
savings
you're right,
account?
because you did like Drosky did.
You don't have a
Where you
savings account.
put like half to
So you have
everything,
$100.
like
to
top
your-
and bottom.
And we're like,
And then you
you
can,
know?
I don't even
no,
have a
no, you
savings
can't.
account.
That's just the second way I'll show you.
Oh,
You're
okay.
fine.
Do you think that's
What were you
wrong?
looking for?
I think that's actually, hey, I actually think that's a longer method.
It is a longer, and that's why he thinks it's dumber. His way's smarter, but it takes more
No, no.
thinking to do.
No.
This is no, you doesn't pay. You want us to think inquisitively, but we don't.
That wires back.
You've been working for a couple of years now. You should have
I
accepted
put one
it.
time.
You gotta put a little bit, open a savings account.
Oh,
put a
okay,
little
no,
bit.
okay.
I can't imagine.
I don't know.
So you did yours, I did yours on like a girl's did.
I don't have that house thing.
It'll be,
Yeah,
that'll
that's
be
why I
the
was
second
looking
way.
around for a little minute. I'm actually, I'm just looking for this answer. Money when I get.
Yeah, so you did it like him.
Actually, my savings
So I
account.
actually, you guys got it right.
I didn't realize
Right
I
now,
was
I
doing
wish
it.
I had
No, I
savings.
just I agree.
So this
You're
job,
thinking
I
big.
$400.
Maybe I shouldn't have went out. Like, I can afford a ticket like that, but I
What?
hate to pay like, man, maybe I shouldn't have went out to the last year. I don't think I would get that.
No, I haven't spent any money off my.
You gotta do the training before you
It's-
learn
I
just did it times it
It's funny that I've only seen the one way of doing this, so.
My way?
Yeah, the
I
more
literally did
challenging
it
way.
your
Justin,
way.
that's what it's
I did
way
it
the
your
highway.
way.
I wanna see yours.
Oh my gosh, you literally
Oh, did I?
did it.
Mr.
Yeah, you
Word,
told
is
me
it
that's
your
right,
way
that's
or
how
the
I showed
highway?
you.
Yeah, that's how I did mine.
Is it your way or the highway? No, Nicole,
No.
Nicole, that's the other one. The highway is over there. That's the other
Okay,
one.
alright, hey,
highway.
I still did it that way.
okay, hey, let me walk through this first method, then I'm gonna walk through the second method, which appears to be how 90% of you did yours, okay?
I feel like that's
So-
not a right statistic.
Alright.
You shouldn't say that. I'll figure it out.
No, I still pointed in the general direction
Yeah,
of the
but
highway, I
we
just
can
forgot
use
that.
statistics.
How it's
There's
supposed to
one.
What?
There's a
Alright.
closer one?
Yeah.
This is how I would do mine.
It's gotta be like 94.
Okay, I know that with the quotient rule, you can put the half on top and bottom. I'm not going to. See, what I'm gonna do is I'm just gonna do the straight chain rule from where I'm sitting right now. I'm not gonna distribute the half. You can put the half top and bottom. So-
Whoa,
so
that's so smart.
how I'm gonna do mine-
Kiddos.
So this is my original function, and a lot of you just put half on top and bottom, and then you went through the derivatives. That's the second rule way I'll show you. So what I'm gonna do is I'm gonna do this. It's the overall chain rule. You drop the power up front.
Justin, shut up.
You drop the power up front. You subtract 1 off the power, so you get negative half. That's subtracting 1 off the power. Then you take the derivative of the inside. You multiply by the derivative of the inside. Well, the inside is just a fraction. So the derivative of the inside is derivative of the top times the
What do
bottom.
we have to do, the quotient rule?
Yeah, it's quotient rule. Minus the derivative of the bottom times the top all over the bottom squared.
You are so smart, Nicole. Why?
That's how I would do mine. Now, don't get me wrong. A lot of you did yours differently than mine.
Excuse me, what?
Because that's the derivative, that's the chain rule. You drop the power up front, subtract 1 off the power, and then the derivative of the inside, which is just a fraction.
Which
That's
I'm
just a normal fraction.
serious?
Now, don't get me wrong. The way that some of you did yours is not wrong, it's just different, right? So that's the beauty of this, is that we can have multiple different answers, but you are getting to the same result. Because what I saw is a lot of people did this, which is fine, was kind of what I was expecting to see, is that a lot of people would distribute the half. So before they started, this is what I saw a lot of people write. Which is fine, this is just the original function written differently. And then from here, right, from here you found the derivative then, which is fine. Which is just a different look to the problem. So you're still displaying to me that you know how to find a derivative.
I know exactly.
Now, here's what I asked you. If you're gonna choose to do your problem like this, which a lot of you did, just make sure that you write this problem down first, like this way you're starting your problem before you find the derivative. That way I know what you did before you started. Like, because me, this is how I think of that problem. But if you started yours like this, yeah, your answer will look differently than mine. Because you're gonna have to do 2 chain rules as opposed to my 1. Because you have, when you find the derivative of the top, that's a chain rule. When you find the derivative of the bottom, that's a chain rule.
You could, you could do, which would be even one more step. You could make that a negative half and put it on the top.
Oh, Yeah.
Oh, yeah.
Oh, yeah, that's good.
Oh, yeah.
All right.
Great to do it.
So yeah, so here's the derivative of the top,
Really
times
can't
the
mess
bottom.
it up.
This is times the bottom. And then we're gonna have to subtract the derivative of the bottom, which is this. This is the derivative, this is the derivative of the bottom, times the top, all over the bottom square. And this is what I was getting, I heard somebody say that they're taking the bottom, and when you square the half,
It's just.
it's just, yeah, when you take it times 2, it would just be 1. And that threw me off at first, because I'm like, that threw me off, because on mine, and again, you wouldn't need to put the 1 there. On mine, I was like, I didn't do that, because I just did mine by one overall chain rule, not 2 of them. So I never had to deal with the 1 of mine. As you can see, 2 different looking answers, the same exact result. But it's because you started with your problem looking different than mine. Okay, questions?
No.
All right, let's go to the next one. All right, now, hey,
You really just should use alcohol and edit.
I do not. Hey, when Nicole finishes her book of your quotes, are you gonna publish it on your,
It's currently 9 pages long, typed up.
He's so sorry.
I'm scared of what you have. All right,
It has
So-
some-
You've been saying a lot of inappropriate things or what?
well, that's what I'm worried about. Like, what have I actually said? All right. Okay, so on this problem, it is a product rule, and then you have a chain rule in the second part of it.
Well,
So-
I just read it.
So if I'm gonna do this, I'm gonna do it by a product rule. I'm just gonna do this one for you really quick. This is how I see mine. Derivative of the first. This is derivative of the first times the second, which is e to the x squared, plus the derivative of the second, which is just e to the x squared. But since that's a chain rule, you have to take it times whatever the derivative of what's inside e to the x. Well, the derivative of what's inside e to the x, the derivative of this is a 2x. So that's a chain rule using e. Its derivative of e is just e, but if there's anything weird and complicated, you have to take the derivative of that thing. So that's where the 2x comes from, times the first, and this would be the final answer.
So like, what would that equation represent right there, that randomness?
Well, definitely, if you were to distribute, and again, this is the slope of that curve. If I was looking at the original problem, that is definitely an e function, so it's definitely a curve that is curving very steep, right? Very steep. And then the idea is that it also has a quadratic attached to it. So it's actually like kind of like a fourth power. So the tails be going the same direction. You'd be looking at maybe a couple oscillations up and down. Okay. I'm just kind of guessing. This is what kind of I'm feeling like it's gonna be coming out. Something like this. Or it probably
What
has
does
like
that represent?
probably like 2x intercepts.
Mr. Ward,
But
That's like.
but since it has an
How would you
E,
like get
since
there?
it has an E, I would
There's gonna be-
expect this tail to be more like, it probably like oscillated down,
Oscillate, that's what fans do.
where it kind of like, it started off slow and then it ramped up because of the
Where would you
EDX.
find this graph? Is what I'm saying.
No, I just made that up.
no, I didn't
Like-
make that up.
So this is just, there's no real practical.
On that one, no, that was just made up. So, I was just trying to give you ones where you
Math
find
is actually for,
Alright,
it's
hold on.
true.
Alright, let's move on.
What if the person who originally came up with math is wrong?
Alright, okay, this
Who came
one,
up with
makes too much
that?
sense.
so, okay, here's this one. Same exact idea, it's definitely a chain rule. So you do the derivative of the outside where you drop the power down.
You can turn that into 1 over
Careful,
6.
Mr. Ward.
No, I would drop the power out front, subtract 1 off the power. So if I subtract 1 off the power, this would turn out to be a -5. And then times the derivative of the inside. The derivative of the inside is 6e to the 4x times the derivative of that 4x, which is 4, plus the 7x to the 6.
Wait, whoa.
Because it's, the inside is just doing normal power rules,
Excuse me.
but that's a chain rule.
The 4 came from the 4x, but I don't want to know why we got it.
Because it's like doing this problem, where you would drop this 7 out front, subtract 1 off of it, times the derivative of what's inside. right? Well, the derivative of x is a 1. So you guys are just so used to writing
Right.
7x to the 6th. Well, that's what you're doing here. It's just 6e to the 4x. You're taking the derivative of this, which is like dropping the power down, doing your thing, but there's no power, it's just e. So the derivative of e is just e, right? So it's just going to be e to the 4x, right? We've been taught like derivative of e's are just e's. But since it has something inside the parenthesis, you have to take and multiply by that out back. So the derivative of 4x
Oh, so
is
you're doing a chain rule within a chain rule?
yeah.
Okay. I just, I don't know why we just put like 4x minus 1. Because that's what I would write. I'd write 4x minus 1. Yeah, that would work.
Well, we have a question this time on the
You still
test.
lose LO.
Yeah, I mean, you're gonna have,
I
you're
didn't
gonna have,
notice that.
you're gonna have homer problems that look like these.
Okay, but on the test,
Yeah, these are gonna be in the chain.
like that one right
I did
there,
it
square
twice,
root
too,
and then to
didn't I?
the third,
Yeah.
that would be a
Like on the
test
same
question.
Yeah.
Wait,
So
is
very
that one?
good.
But I don't
Fair
pay
game.
attention to time.
Why?
You like that?
Fair game.
That sounds pretty tough.
I mean, you should see your homework. I'm just getting prepared for the homework.
We have retakes, right?
The shot fired.
Let's get one.
Forty-two.
Alright,
YOLO,
Hey.
because you only get one line, so you get one retake, right?
You only get two.
now, why I picked this last one? Why I picked this one? This is it's a product rule with a chain rule and another chain rule on it. What I would probably do on this problem, I would probably change the look of it because I don't like that there's so many things going on there. There's like a chain rule inside a chain rule inside a
It
chain
could
rule.
be 1.5.
So-
Oh my gosh.
So what I would
Do
do,
it.
I would change it to be this. So, and I think you even said it. I would change this problem to start with
No, no.
to just be 3 and then put a half big multiplied on it, right? Because it's x, it's this whole thing to the third power to the half power, that's what makes the radical. Well, if you multiply this, I already heard it, it's 3 halves,
There you go.
right? That's how I would start my problem here. I'm more comfortable looking at that, because that's a normal chain rule.
That is so normal.
So, this would be, you drop the power out front,
Subtract one.
you subtract 1 off the power. So if I subtract 1 off the power, it's half.
And then
For sure.
do
And
it.
then times the derivative of the inside. Well, the derivative of the inside is a product rule. It's a product rule. Two things being multiplied together, and so you have to do the product rule for the thing on the inside. So this is 2x times the second
Okay, this one's not that bad.
plus the derivative of the second times the first.
It really did.
Because remember, when you take a derivative of this, it's natural log 5 times 5x, and then times the first.
I feel like you could teach a college class about.
Sure, would you have a master's degree?
No,
Why not?
no.
Would you?
Math is incredibly difficult to get. So, I don't
My
know.
aunt's taking a statistics class for her master's right now.
That's not easy. That's tough.
It's not easy.
Do you think you could do it?
You could definitely,
What could
but she's
never-
not, she's not getting her
Do
master's.
you think you could be a doctor of
It's not,
math?
it's not.
Like if an equation is
And
broken,
assignment
you
due
fix
tonight.
it?
I started it, but
Okay.
I don't know how to do.
We good?
We can call you
Okay.
master.
Alright.
Oh, we're in 6-0?
Okay, here's your homework. Okay, in the beginning, hey, in the beginning, I gave you a lot of odds. I want you to be able to check those first ones in the back, make sure you're doing them correctly. They're all short. You do not have to foil everything out. Now, here's the bad news. I know I gave you a lot of odds. The odds in the back, they expect you to like foil it all and simplify it.
Oh.
So, you can go, if you check, the certain websites you guys have, they'll at least know like where you started and they'll show you the simplifying steps. So you can at least see, did I get the first step right when I first wrote it down? That's all I want. You do not have to foil everything and simplify it all the way
So we can
down.
say-
Write out the first step and then move on. Okay, it looks big and menacing, it's a lot of odds, a lot of evens. Just get the setup, move to the next
So you
problem.
would recommend?
I'm worried about these last few because there's so many rules we have to do, we're mixing them all together. We only have a few sections left to do here. We have to graph, find second derivatives, all that good stuff, be ready to go.
I didn't know it did.
God, oh my god, my contacts just shut off for a second.
Mr. Ward, are you recommending me to just use Slater for this assignment?
52.
Do you know
I don't
when
think
that
you'll need
happens? Oh, I thought you just said this was a tough assignment.
No, if you're gonna try to like simplify it, it would take a long time.
Tough is relative.
Hard.
Tough could be sandpaper.
Really?
Tough could be meat. Tough could be a meat.
Inadequate state. Inadequate, like, you know, I didn't think we're like,